So we have another service uh, on the EC2 dashboard itself. It's called Elastic Load Balancing. Okay. So as I mentioned, Elastic means that that service can automatically scale itself. Anywhere you see Elastic, it means it can scale itself. So what is the meaning of Elastic Load Balancer? Or if I talk about what is a load balancer in general. So a load balancers, from a definition point of view, you can say that whatever targets or whatever machines or whatever containers you have where you want to deploy your application. Okay. So if you want to distribute the traffic among all those targets, okay, as I mentioned, the targets can be anything. It can be EC2 instances, it can be containers. Okay, you want to distribute the incoming traffic from users to all those various targets as part of your application deployment. For that, we use load balancer in general. Okay, so the most important role of a load balancer is to balance the load across the targets which are running behind the load balancer. Okay, so if I just show you a diagram a little bit. Yeah. So suppose you have two EC2 instances which are running as part of an auto scaling group, which we saw yesterday, that you can create multiple EC2 instances as part of an auto scaling group. So now if you want to balance the load on these two instances, okay, for example, we have these multiple users trying to access your application. So you can put an elastic load balancer. So Elastic Load Balancer is the load balancer service in AWS. Okay. So in some other cloud platform or in some other place, you will see just load balancer or some other name, but the concepts behind this ELB is it uses all the properties of a standard load balancer. Okay. So the most important job of a load balancer is to distribute traffic amongst the different targets which are uh, uh, associated with that elastic load balancer. Here I'm talking about AWS. So if you have an application hosted on these two EC2 instances and you want to distribute the traffic, you can use an ELB in general. But ELBs do some other tasks also, which you should know. Okay, apart from distributing the traffic, apart from routing the traffic from the clients to the target machines, it also works to identify faults, or I mean the faulty targets. So it is able to perform health checks also on its target machines. Okay, so ELB has its own health check criteria that you can set in the configuration of this ELB resource in AWS. So it can perform health checks on all the targets and decide whether the target is healthy enough to send the request to. If it's not healthy, then it's not going to it's not going to redirect the traffic to that target machine. It's only going to send the traffic to the healthy targets. One of the things it can do. Also, if you remember that each EC2 instance, I'm just taking an example of EC2 instance because we haven't studied containers. Okay, I'll tell you how ELBs work with containers also when we reach there. So each EC2 instance is always catered within a region, and within the region, it will always be catered in an availability zone. Okay, so if you want to balance the load, if you want to balance the load in different availability zones also, okay, it is called a cross zone load balancing. So that is also possible with elastic load balancers. Okay, so it is able to do multiple things is what I mean here. Okay, apart from routing the traffic to the targets and distributing it, it can perform health checks. It is able to do a cross zone load balancing. Also, there's one more feature which is often asked in the interview is sticky sessions. Sticky sessions mean that suppose you have two instances running and the users are connected to one machine at a time. Okay, so if you enable sticky sessions on ELB, which means that that particular user will continue to use that particular instance only. Okay, till the time he's connected to the website. So only in some cases you would want to use it. For example, the user is filling out a form. Okay, that form data, for example, it is stored in the EC2 instance itself. Okay, so we don't want like I mean, half data to be stored on this instance and half data to be stored on other instance. Okay, you would want until he is able to finish that form, submit it, he is connected to the same instance. So in this type of scenario, you can enable sticky sessions for the users, which means that whatever instance he is trying to access via this ELB endpoint, he will be connecting to the same instance until he terminates the session, like that. Okay, so once again, a very special feature, not very, I mean, useful in all the scenarios, but in some scenarios, if you want to enable sticky sessions, you have the option. So now you see this single resource can do multiple things for you. Also, if you see, since it is able to perform health checks, it is also providing fault tolerance architecture to your application. Okay, so this is the word that you have to use in interview also. ELBs are responsible for providing us a fault tolerant architecture for our applications when we use them. Okay, so these are some of the features, some of the most important features of ELBs in general. Okay, so I'll just talk about some theoretical stuff so that we can just learn about it from interview point of view, and then I'm going to show you a demo also, which is going to cover all the things. So ELB is a resource that automatically distributes your incoming traffic across multiple targets across multiple targets, such as EC2 instances. It can be containers, or it can be some IP addresses in one or more availability zones. It is able to monitor the health of its registered targets and routes traffic only to the healthy targets. ELB scales your load balancer capacity automatically in response to changes in incoming traffic. So ELB is a service that is managed by AWS. We don't do any scaling for an ELB resource. It is all taken care by AWS. Okay, so it's a highly scalable service. Okay, so depending on the amount of traffic, it's going to scale itself, and that's why it's called elastic. Then load balancer benefits. A load balancer distributes workloads across multiple compute resources. It can be virtual servers. Using a load balancer increases the availability and fault tolerance of your applications. It is all written on the official documentation of AWS. I've just copied a few important points, but if you check the documentation, it's a huge documentation. Okay, it requires a lot of time. So I highly recommend after this session that you, I mean, go through that and try to learn some extra things about this service, especially this service, I will say. You can add or remove compute resources from your load balancer as your needs change without disrupting the overall flow of requests to the application. So at any point of time, you can deregister any targets, and it's going to ensure that the traffic is not routed to those targets which you have already deregistered from your Elastic Load Balancer. So all that is taken care by ELBs. You can configure health checks, which monitor the health of the compute resources so that the load balancer sends request only to the healthy ones. You can also offload the work of encryption and decryption to your load balancer so that your compute resources can focus on their main work. The meaning of this is, with ELBs, we can attach SSL certificates also, which means that if you're configuring a web server on your EC2 instances, I'm just taking the example of EC2 instances, you don't have to configure any SSL certificate on the EC2 instances. It can be done on your ALB also. So that SSL offloading is taken care by ELBs. How it happens? Let me explain you that also in one line. So suppose you attach one SSL certificate that is attached to your ELB. Okay, so the traffic is going to be encrypted via SSL, and then it's going to decrypt the traffic and send it to your target instances. Okay, so it performs encryption and decryption, and whatever response is coming back, once again, it's going to decrypt it and then send it back to the user. So all that SSL work is being taken care by your ELB once you attach an SSL certificate to it. You don't have to configure SSL on your EC2 instances. Okay, so if you are using an auto scaling group and you have like multiple instances being created and terminated, so in that case, all you have to take care of is your application business logic. Okay, you don't have to focus on these things. So That's why it is a very useful feature. Okay, where I was here. Then we have four types of load balancers in general. Okay, application, network, gateway, and classic. Just forget about this classic one. It is a legacy load balancer, which is not available for use. I mean, it is available for use, but no one uses it at the moment. It's like the very first load balancer with only a few features available, so nobody uses it. And these three are the most important ones. And for your container applications, these two are the important ones. And this is the most important one. So application load balancer, network load balancer, and gateway load balancer is what you need to learn. So if I talk about application load balancer, okay, once again, the name of the service is Elastic Load Balancing, ELB. In ELB, you have four types of load balancer. The first one is ALB, application load balancer. Whenever you are creating any application or network load balancer, you're going to configure a resource inside the service. It's called listener. Okay, the listener is going to check for connection requests from the client. So this is the resource that is always listening for connections, incoming connections from the clients, which means from the users, or it can be application also in some cases. It uses a protocol and port combination to listen to an incoming connection. And each listener will have a certain rules which is going to use to route traffic to registered targets. So as I mentioned, a target group is a resource that routes requests to registered targets on port protocol that you choose. So once again, whatever, I mean, a port protocol that you have choose as part of your listener configuration, the traffic is going to be routed on your target instances on that protocol and port combination. You are also able to configure health checks as performed on all the target registered to a target group. All this I'm going to show you in a demo also, but it's important to understand from theoretical point of view also. So why did I cover that OSI model initially? Because each resource, or I mean, most of the networking resources align to the features of one of the layers of the OSI model. So this application load balancer is a layer 7 load balancer, which means that it uses all the features and protocols of layer 7 of the OSI model. So that's why it's important to understand what this layer 7 is. I'm talking about the presentation layer, if you remember from the OSI model. So this ALB uses all the features of OSI layer 7 and it's called OSI layer 7 load balancer. Okay. The sorry, the application layer. Sorry, I'm talking about layer 7, which is the application layer. It uses a routing algorithm. So each load balancer that you create, it uses a certain algorithm to route traffic to the registered targets. For an application load balancer, it uses round robin as the default one. This question was asked to me in an interview long time ago, and I was not able to answer. I wasn't sure. Okay, so once again, you should know the default algorithm which load balancer uses. For ALB, it is round robin. The meaning of round robin is, suppose you have three users, so we have three requests, okay, coming to this ELB. So the meaning of round robin is the first one will be sent to this one, the second will be sent to this one, then the third one will be sent to again the first one. So it's like round robin way. Okay, so each one will get its chance. Okay, one by one. 1, 2, 3, 4, 5, 6, like this. So it's called round robin way of routing the traffic. And this is the default algorithm. But you do have the option to change it to another routing algorithm. It's called least outstanding requests routing algorithm in ALB. You have the option to change it to this one. So the name itself suggests the target machine which has a least outstanding request at a given point of time, the request will be routed to that target if you choose this algorithm for your application load balancer. Okay, then also since it's using layer 7, which means that it has some additional features like it supports path-based routing. So if you're hosting a website and it has some paths, so for example, if you access slash kids path on a website, it's going to take you to another page. Okay, then slash footwear page is going to take you to another page where you will only see the shoes. department. So in a particular website, you can divide it into separate parts, and you can use this path-based routing to route the traffic, the traffic from the users to different parts of the website. And this is what the big, e-commerce websites uses. Okay, they use this path-based routing. So whenever you are searching for any related to shoes or apparel, so you directly reach that point. Okay, after you hit search. So all that is being done by via this path-based routing behind the scenes. You also have host-based routing. This enables you to support multiple subdomains. So once again, you have the option of choosing a multiple subdomains as part of your application load balancer configuration. Okay, so maybe you haven't done all this, or I haven't done all this, but you should know this, that these are the features of ALB. Okay, then as we just mentioned, that it supports multiple target types. It can be EC2 instances, or it can be IP addresses. We use IP addresses when we are working with containers. So ECS, Elastic Container Service, is a service that can be used along with your ALB, and in that case you'll be using IP addresses as your targets. Okay, but we'll be talking about EC2 instances for now, and when I reach there, I'll talk about ECS and how we can use ALB with IP addresses also. Then the second type of load balancer is called NLB, Network Load Balancer. Once again, it has a listener that's going to check for connection requests from clients using protocol and port that you configure, and it's going to forward the request to the target group. NLB supports TCP, UDP, TCP underscore UDP, and TLS protocols. Okay, this is because it is a layer 4 device. Okay, which means that it's going to use all the features of layer 4, which is transport layer. So in transport layer, you have TCP, UDP, and other protocols. Okay, if you see here, application load balancer uses HTTP. Okay, I haven't written here, but this layer 7 means it uses HTTP and HTTPS. Okay, in general, in most cases. But with NLB, you're going to use TCP, UDP, okay, which is layer 4 protocols. So, so this is how these things matter. So if someone asks you about this, you have to tell these things, that uh, network load balancer is a layer 4 load balancer, which means that it uses the features of transport layer of the OSI model. Like that, you have to start, and then you can talk about it, how it works. So the things are quite same in ALB and NLB. Only a few things differ. You're able to perform health checks also, and it's going to perform health check, and it's going to send the traffic only to the healthy targets. Okay. One thing, if you are asked, or given a choice, that if you want to handle millions of requests per second, which ALB you should use? It should be NLB. Your choice should be NLB. NLBs are faster. It's able to handle millions of requests because above layer 4, it does not process any information. So that's why it is faster than ALB. With ALB, you're using layer 7, so it's going to do a lot of processing of data. But if you have a requirement where you have to handle millions of requests per second, so in that case, just go for NLB. When you enable an availability zone for the load balancer, Elastic Load Balancing creates a load balancer node in the availability zone. So this is like the generic behavior of ELB service. Whenever you are creating any load balancer in any availability zone, what AWS does, it's going to create a node. Okay, it's going to create a load balancer node in that availability zone. By default, each load balancer node distributes traffic across the registered targets in its availability zone only. If you enable cross zone load balancing, which I was talking about, each load balancer node distributes traffic across registered targets in all enabled availability zone. For TCP and UDP traffic, the load balancer selects a target using a flow hash algorithm. So with NLB, the default algorithm is flow hash algorithm. So flow hash algorithm is a special type of algorithm. It's going to use a different information from the incoming target. For example, it's going to check for the protocol, the source IP address, the source port, the destination IP address, the destination port, and the TCP sequence number which gets generated. So all that information will be taken into consideration, and then it's going to decide where to route the traffic. Okay, so this is a different type of algorithm it uses. It's called flow hash. ELB creates a network interface for each availability zone that you enable. Each load balancer node in the availability zone uses this network interface to get a static IP address. With NLB, uh, whatever nodes gets created in that availability zone, each node is going to have its own static IP address. So once again, if you have a requirement where you want to associate your load balancer with a particular type of application, and you don't want, you want the uh, requirement to be, the ELB should have a static IP address. In that case, you have to go for NLB. Okay, NLBs work with static IP address. Once again, a very important interview question. Okay, if you have a requirement where you want to have a static IP address for your load balancers, it has to be NLB and not ALB. Okay, it supports EC2 instances. It also supports ECS tasks. So it means NLB also supports containers along with EC2 instances. Then another type of load balancer is gateway load balancer, which I haven't got any opportunity to work with. So I just know this on a very high level, but it is good to understand, and you can tell that in the interview also. Okay, right? There's no shame in this because since you are working in a DevOps environment, okay, the container world, so we might not be using gateway load balancer every now and then. Only ALB and NLB are used the most. Okay, but this gateway load balancer is it is related to security. Okay, so it enables you to deploy, scale, and manage virtual appliances such as firewalls, intrusion detection, and prevention systems. It is a layer 3 load balancer, so it works on network layer. It listens for all IP packets across all ports and forwards traffic to the target group that's specified in the uh, listener rule. Okay, so once again, I don't have too much information to talk about it. If you want, you can explore from the AWS's documentation and try to deploy it. Okay, so I've only worked with ALBs and NLBs most of the times, but you should know the name at least. Okay, gateway load balancer is there. Then
Bhavuk, sorry for
yeah,
uh,
yeah, 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 yeah.
thing.
Please.
So the use cases here for the application load balancer or layer 7 load balance, layer 7 application, let us say the application load balancer will be able to help us, mitigating, offloading the traffic, right? For
Yes,
any kind of traffic, okay, for the front facing applications, let us say. Uh,
yes,
but to be specific, what about the IP associated should be also, constant for that, right? It should be a static IP in general use cases, right? For the application load balancer also.
no. Actually, we use the DNS endpoint most of the time.
DNS and
So yeah, so AWS can change the IP address behind the scenes for an ALB. If you have requirement like that, you have to go for NLB in that case.
okay, okay,
Yeah, that's why I
okay.
mentioned it. Yeah,
Mm-hmm.
yeah.
And the most use cases for the network load balancer probably it is not for the front facing. I think it should be within within the internal network or some where we want to use to be specific. Their network load balancer will be able to help us more, right?
Yes, you are right. So
Mm.
generally we have like from one application to the other, you want to route the traffic, you can use NLB in that case. For
Okay, okay,
all the front facing ones, because we have we have to use HTTPS and other features like path based, host based. So we generally use ALB.
okay, okay,
Yeah.
okay. And also the security features which associated with the application load balancer and not with the network load balancer. Let us say where for the DDoS one where we can use with an application, not with the network load balancer.
Yes. Yes.
Yeah, okay, fine.
ALBs are used the most. Yeah, no problem.
Yeah,
ALBs are used the most with container applications specifically. I'm talking about. But as I mentioned, if you have some specific use case like you have to handle millions of requests per second, static IP address, or some specific use case, you can use containers with NLB also. But in most cases, you will be using ALB only.
no problem. Thanks.
Yeah, welcome. Then I was talking about this legacy one classic load balancer. Okay, I don't want to talk about it too much. Okay, it's not that important, but if you want to read through, you can just go to this documentation page, and I just had to compare CLB with ALB especially. Okay, so CLB and ALB have some comparisons, but of course CLB is a legacy one, so it doesn't offer all the features that you see with ALB. Okay, Okay, now I'll show you a demo. So as I mentioned, for auto scaling groups, for elastic load balancers, you have to navigate to EC2 service. It's part of EC2 dashboard. On EC2, on the left-hand side, you can see multiple things. So for AMIs, for volumes, for snapshots, for security groups. Okay, security group is part of APCs also and EC2 also. Elastic IPs, key pairs. Okay, all this is part of EC2 service itself. Your network interfaces, NIC, network interface cards, also you have it on EC2 available. For auto scaling groups, also you have to go to EC2, and similarly for load balancers, you have to go to EC2. Okay, I'll first go to auto scaling groups first. Oh, region has changed. Let's go to US East 1. So I created one auto scaling group yesterday. This was the one. Okay, and before that I created an a launch template also. Okay, I'll just show you one use case that we'll be using. Okay, so it's like a project, okay, that you can understand and explain in the interview also. Just close this one. Yeah. So this is the, I mean, one of the scenarios that you can say. Okay, so for example, I'm just giving a very random example that you are working for an e-commerce website. A fast-growing e-commerce startup is hosting a critical customer-facing web application on AWS. Initially, the application was deployed on a single EC2 instance. As user traffic increased during peak hours, especially during flash sales, the site began to crash frequently, or became very slow. This led to loss of customers due to downtime, increased support tickets and SLA violations, no visibility into system health or load patterns. The DevOps SRE team is now tasked with designing and implementing a fault-tolerant, auto-scalable infrastructure to meet the following requirements. So this is like the problem statement for us. Okay, like one of the scenarios where you can relate this project to. Okay, any doubts in this? What we're trying to do here? All good?
Yes. Yeah, yeah.
Okay. So how you're going to handle this type of scenario from a technical point of view? Okay, you want your application's architecture to be highly available. The application should always be reachable even if an EC2 instance fails, right? Because if we are deploying our EC2 instances as part of auto scaling groups, it's going to be taken care by auto scaling group resource. So even if an EC2 instance fails, and another one will be created automatically by auto scaling group. Then scalability, automatically handle traffic spikes by adding or removing EC2 instances based on CPU utilization. So once again, we'll be using a scaling policy as part of our auto scaling group, and it will be using average CPU utilization across the auto scaling group to scale out or scale in the number of instances depending on the needs, the traffic spikes. Then we also want to enable load balancing. Okay, distribute user traffic evenly using an application load balancer. Then automate the deployment. We will use a launch template, and we're going to use our custom AMI that will have all the configuration of the web server already there. Because when EC2 instances are created as part of the auto scaling group event, then it's going to use that AMI to have the same configuration on all the EC2 instances. Okay, so we have to create one AMI that has all the configuration that we need with all of our EC2 instances that will be created by the auto scaling group. Okay, and then we're going to set up CloudWatch alarms and SNS notifications when CPU usage exceeds a threshold. Also, it's going to take care of cost optimization also, because uh, we'll be using scaling event also during low traffic periods to reduce cost. Okay, we can configure this if we want. We can have like whenever our CPU utilization hits 60%, one instance should be increased, and whenever it I mean goes back below 60%, it should reduce the number of instances. All that is possible using your scaling policy. So I mean cost optimization is also possible. Okay, so you're going to create an end-to-end web app infrastructure using EC2, ALB, ASG, and AMI. you're going to practice infrastructure automation concepts. Okay, this we will do slightly later. I mean, we can use launch templates and instant refresh, but what I'm going to do is I'm going to create everything from the UI for now, and when we reach the Terraform stage, I'm going to automate everything with Terraform. Okay, I'm going to explain how we are using the Terraform script to automate all the things that we'll be doing from UI today. So we'll be using the concept of a launch template that we discussed yesterday. Okay, and one more feature is there, instance refresh. I'll just talk about it before I start the demo. And then we're going to configure a stress test a simulation to mimic real world CPU spikes. So we'll be doing a stress test on our EC2 instance, which is part of the auto scaling group, to increase the CPU utilization on that instance so that we can have the CloudWatch alarm trigger and SNS notification. At the same time, the scaling event is also going to be triggered. And we'll see how auto scaling reacts to CloudWatch alarms is what I just mentioned. Okay. So if I talk about the architecture part, so this is the architecture that we want to deploy here. Okay, let me just walk you through. So if you can explain this type of architecture in an interview, okay, there's no interview that you cannot crack. Okay, because this is the type of real-time type architectures that we'll be dealing with. Okay, so what I'm going to do is you can go ahead and create an IAM user first. Okay, which is going to have admin permissions to create resources in an AWS account. Within the AWS account, within an AWS region, you're going to use a VPC. In real world use cases, you'll be using your custom VPC, but for our use case, we'll be using a default VPC, but it's going to behave the same way, right? But in real world, you will be using a custom VPC. So within the VPC, you will have two availability zones, as you can see. And in each availability zone, you have one EC2 instance, which is a part of the auto scaling group. The auto scaling group will be associated or integrated with an application load balancer. EC2 instances also have a security group to control inbound and outbound traffic. Similarly, with application load balancer, you have the option to configure a security group to control inbound and outbound traffic. Okay, with ALB also, we need a security group to control its incoming and outgoing traffic. Okay, our VPC has an internet gateway attached in its route table so that the users from a public internet can access the website using this internet gateway. Also, what I'm going to do as part of our auto scaling work, I'm going to create one scaling policy. It's going to be a dynamic scaling policy uh, that I'm going to configure with my auto scaling group, and it's going to trigger an scaling event using a CloudWatch alarm. So I'm going to show you this. So we're going to use a CloudWatch alarm and that will be based on average CPU utilization of this auto scaling group. And we'll be setting a threshold value for this CPU utilization. As soon as the threshold is breached, the scaling event in the auto scaling group is going to trigger, and it's going to trigger an SNS notification to my email ID informing that some alarm has triggered and average CPU utilization has breached. Okay, but I don't have to take any action because my scaling event is going to automatically add one more instance to my uh, uh, architecture to support that increased CPU usage. Okay, so it's so whenever uh, large number of users are trying to connect to an application at a certain point, the CPU utilization can increase. Okay, across the auto scaling group. So it's going to add one more instance to it so that it is able to support that increased CPU utilization. So this is the architecture that we're going to follow. Any doubts in this? How did I explain it and how you are going to explain it? If someone asks you about uh, particular project that you have done. So this is how you can explain this. You should have this diagram in your mind, and then you can explain this to the interviewer that this is the project that I have done, and this is one of the real world projects that you can say. Any doubts? How did I explain it, and how you are going to explain it in the
Both will
interview?
be public subnet. Both will be public subnet. Yeah.
So in general, it depends on the type of application. Here we are talking about an e-commerce platform, for example, Flipkart, Amazon. All these are on, I mean, public internet, right? So in that case, it's going to be a public subnet. But if it's for for a company where you want to keep everything private, in those cases, it will be private subnet. and only some internal users will be able to access the website. Only this is the uh, uh, difference. So it's up to you which one you want to use. If you want to use a type of a public e-commerce website, then you can use this concept. You can explain it as I deployed my EC2 instances in public subnet. But if it's a private uh, application, in that case you can use a private subnets also. So for example, you can give an example of like there was an application which is used to give some information related to uh, data for the company. I mean, it can be any data. For example, if I talk about a law firm, which I've been part of, so there was some application which were only private to the this company employees, and only using a VPN you can connect to the website from the company laptops. So all that was completely private. So all the entire app architecture was exactly the same. Only thing was the instances were deployed in the private subnet, and everything was private, and there was no internet gateway on the VPC. So in this way you can explain in that way also. It depends what kind of use case you want to use. Any other doubt, guys, related to architectural diagram? If not, I'll start creating the resources. Okay, so this is the architectural diagram, and I've already mentioned the steps also that you can also follow step by step. Okay, I'm not going to create an IAM user here to save time. If you want, you can create an IAM user with admin permissions. You can keep any name of the IAM user if you want to. So I'm going to use the root access only to save some time here. And I'm not going to create security group also because I've already created. Okay, and I've already showed you in the past also how to create a security group, how to enable the inbound and outbound traffic depending on your use case. So all that is being done. And yesterday I created one launch template and auto scaling group also. So this is also done for me. Uh, Launch an EC2 instance from a launch template. So this I'm going to do now. So all these three steps have already been done. Okay, for me. So I'll start with step 4. So I'll go to my console, and this is my auto scaling group. The name is demo ASG. If I go here, I've set the desired capacity minimum max to 0 to delete the number of instances so that I can save some cost. Okay, so now I'm going to edit it, and I'll keep it as 1 desired capacity, minimum as 1 and maximum as 2, and I'll update. This is going to create one instance for me as my desired capacity. So instance management, if you just hit refresh a couple of times, you will see one new EC2 instance being created after I change the desired capacity of my auto scaling group. Okay, just wait for a bit. It's taking slightly longer. We'll just wait. It's updating capacity status, as you can see. Okay, and one more thing I want to show you after I create this. I'll just show you after we have the instance available. So if I go to template tags, source tags. This is not the one that we want to use. This is a separate instance to auto scaling group. Okay, as far as I remember, this is an earlier one that I created. We'll just wait for it to create an instance first. Okay. So if you see here, after I updated the capacity, the instance wasn't created. Okay, if you want to see what actually happened in your auto scaling group, you can go to activity section and check for the logs here, activity history. So launching a new set instance, reset is one or more target groups not found, validating load balancer configuration failed. Okay. So since I mean, doing some testing yesterday, I created one ALB also. I attached it with the auto scaling group. So I haven't disassociated that. So that's why it's failing. So what I'll do, I'll remove this and I'll update. And now it should be able to create the instance. Okay, so you can check all the activity on your auto scaling group in activity section. Okay, so now it has been able to launch the instance. So if you go to instance management, you will see the new EC2 instance after I disassociated the target group that was part of the ALB yesterday. Okay. A few more things I want to talk about. Just a moment. Yeah. So a few things about auto scaling group which I didn't talk about yesterday is these things. Life cycle hooks, very important from interview point of view. Okay. So life cycle hooks is a way by which you can create a custom action. For example, when you launch an instance as part of your auto scaling group, okay, you know that that instance is not going to be ready until 5 minutes because it has some software packages that it's trying to install. Just in case, in that case, you can get a life cycle hook to, I mean, create the custom action which is going to include all the steps that you want to have, and uh, only after this, I mean, all the steps have been performed, the instance will be in ready status to accept the connections. One more way is if you want to capture all the logs from your EC2 instances which are part of the auto scaling group. For example, any instance fails, okay, terminates, you know that the auto scaling group is going to get a new one. But uh, before the earlier instance, I mean, gets terminated, you want to capture all the logs from it. So you once again you can create a life cycle hook for that. And I mean, what it's going to do is it's going to capture all the logs, that life cycle hook, and store it in some storage space. Okay, whether it is an S3 bucket or some of the third party application that you've configured the access to. So you can create life cycle hooks to have some custom action enabled on instance launch and instance termination. Okay, that that can be done. Also, you have something called as warm pool. So warm pool is again like you create some instances in advance that will be a part of your main client traffic. For example, you know that the EC2 instance is going to take like 2-3 minutes to be in ready status to accept the connection from the client. So you can create some instances in advance and keep it in the warm pool. So as soon as any instance fails or terminates, the instance from this warm pool is going to be added to your main uh, uh, auto scaling group to accept connection from the clients immediately. So this is used when you have some really like mission critical application which uh, where you cannot afford to have like, I mean, 2 minutes of delay also. Okay, because auto scaling group is going to take like 1 minute or 2 minutes to create the instance and and get it to ready status. So you have the option to create some instances in advance and keep it in warm pool, and as soon as it requires, it's going to add the instance from warm pool immediately. So there will be no delay at all in getting an instance, I mean, in creating an instance and getting it ready to accept connection from the clients. So this is, it's called warm pool. So these two are very important concepts, okay, to understand from interview point of view. Then instance refresh. One more thing I want to talk about, instance refresh. So you know that auto scaling group, it uses launch templates behind the scenes, and each launch template can have various versions of it. Okay, suppose you have uh, 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 You have made some changes to your AMI, your Amazon machine image, which was part of the launch template. And now you want to apply those changes to your auto scaling group, because the auto scaling group already has some instances and it is running with the previous AMI. Now you have updated the AMI. So how to update the AMI? You can use the concept of instance refresh. So what it's going to do, it's going to perform a rolling update on your auto scaling group. So it's going to take down one instance, okay, and then update. And then it's going to create the new one with the new AMI. In this way, it's going to take down one instance at a time and keep updating one at a time. So to uh, perform rolling updates of your instances with the new AMI, you can use the concept of instance refresh. Okay, the rest everything is now and only activity where you can check the events that happen with your auto scaling group and monitoring. You can enable auto scaling group metrics collection
Uh,
also. Yeah,
Can
any
you please
doubts?
repeat that one? Okay.
Which
Rolling
one?
group,
Okay, rolling updates.
last one.
Okay,
Yeah.
okay. So let me show you the details. Okay, if you check the details of this auto scaling group, it is attached to a launch template. Okay, if I open the launch template, this launch template is using an AMI, Amazon machine image, which has all the configuration that I want as part of my EC2 instances. This is correct? Understood?
Okay.
Right now, if I make any changes to my AMI, for example, there's a requirement to install some additional software on your instance. So what I'm going to do is I'm going to go to actions. Then I'm going to create this modified template, and then I'm going to create new version. Okay, and I can update my updated AMI here, and I can create another version of it. So if you create another version of it, the already running EC2 instances are using your previous AMI, right? You want to update your instances with the new AMI that you have updated with your launch template. So how are you going to do that? You can do that using the concept of instance refresh here. You can start instance refresh, and what it's going to do, for example, you have two instances which are part of your auto scaling group running with the older AMI. It's going to take down one instance and then create the new instance with the new AMI, and similarly it's going to do for the other one. So it's going to take one instance at a time and just replace it with the new instance with the new AMI. So it is called rolling updates. Okay, performing rolling updates, meaning you're not taking the entire app down. I mean, you don't need any downtime for this. You're doing it live in production, and you can perform the rolling updates one instance at a time. It might still have some impact because you're taking down one instance, but it's not going to take your application completely down. Is what I mean. Understood now?
Yes,
Okay. If any doubts, please let me know. Okay, I can repeat or I can explain in another way. Okay, I'll show you actually what I'm saying right now. So let's just, okay, so we have this one instance running now. Okay, so I'll just click on this instance and suppose I'll just connect to the instance first. Sometimes you will see when you have custom AMI, the login user is given as root. So you have to change it back to the standard user. So I'm logged into the instance, which is part of my auto scaling group. Okay. Now if I want to install some package, for example, anything, let's just okay, I just want to keep some data, for example. I don't want to install any package. I just want to keep some additional data. For example, any file. I can get any file, like a test file, .txt. And I have some random data that I am adding. And I want to include this with all of my instances. Okay, just as an example. I've saved it. Okay, the file is already there. Also, I want to install. Okay, let's install web server also. Though it is already installed. Okay, wait, guys. I think this can confuse you a little. Let's go step by step. Okay, so I have this document that I'm showing you with all the steps that you have to perform to do this project. So step one, step two, step three, I've already done. Okay. Step 4 is launch an EC2 instance from launch template. That also I have done as part of my auto scaling group. This instance has been launched. This instance is already part of the launch template and my auto scaling group at the same time. Then I'm going to access to the EC2 instance and register a custom AMI. So I'm going to create my custom AMI is what I was showing you. Okay. I want to install and configure a web server on my EC2 instance. Okay, so for that I have to log into the instance. So I'll just re-log in. I'll go here and I'll re-log into the instance. And then I'm going to perform all these steps one after the other. These steps, which is given to configure and install my Apache web server. Okay, I'm using the example of Apache web server. So I'll become root. So I'll copy the command. I can copy and paste the command as it is, and it's going to work. Become root. Install this package, httpd. I'm using Amazon Linux, so I'm going to use yum package manager. The package is already installed. Then I'm going to, okay, one more thing I have to install is yum install git -y. Install a git package. It's also installed. Next, I'm going to clone the repository. Okay, so this is the repository that has the application code, the main application codes. Okay, so because our website is going to look like a real world website. So, I mean, I have some, already available, code from Google. So I've already included in this GitHub repo. So you can use this. So I'm going to clone the repository. Okay, it already exists actually. So it's giving me the error, but for you, it's going to download. If you do ll, you can see this directory already downloaded on my machine. So it's going to give me this error. But for you, it's going to be first time. So you're going to clone the repository. So Tej and others, what I'm trying to do here is I installed one package called Git. So Git is a tool which can be used to interact with remote repositories, remote, repository from all the platforms. So here I'm taking the example of this GitHub repo, but it can be any repo. It can be in GitLab or some other platform like Bitbucket. So we have these different platforms where you can keep your application code and all the files related to a particular application. So I have this repository which is already created by me on my account on GitHub, where I've stored all the application source code files that I need for my web application. So to download this uh, to my local machine, I'm using this Git tool, and this is the command I'm using: Git clone, and then the URL of the repository. Okay, in this way, you can download the entire source code. Now, if I go inside this directory, you can see all the source code available here. Okay, so this is the source code. If you do ln assets, you will see a lot of different files available. So all these are going to ensure that I have a type of a real world website that I'm trying to deploy. Okay, all that it's doing. After that, I'm performing this command. It's going to copy. I'll just go one step back. So this command is going to copy all the contents from the downloaded repository. So within the repository /star, and it's going to copy it to the standard Apache page where from where the website is going to download the index page, which is /where/www/html. Okay, so it's going to copy all the stuff. So you can just copy and paste. Since I already have it, so I don't have to do it. But for you, you can just run this command. It's going to. So I'll just come out of it because it's already there in my this directory, and you can check it also. If I go ll/where www.html, you can see all the contents are already there. So since I ran this command yesterday also, then I'm going to start my service. It's going to start the service. This is going to enable the service. Okay, we need to enable the service because when EC2 instance is getting, it's going to be getting from the scratch. So you should have the service enabled so that HTTPD is already running as soon as the instance becomes ready. You can check the status also once if the service is running or not. Okay, it's in running status. All good, active running. And you can check the status of the website on your machine also. If you do curl localhost, you will see this type of HTML based content, which means that your site is working on your machine. Your website is working on your machine. Okay. Now I'm going to do update the launch template with the new AMI. So I have to create one new AMI. So whatever configuration I needed, I've already done on the instance. Now I will get an AMI to save this entire configuration of steps that I've done right now to an AMI that I can then attach to the launch template, and it will be used by the auto scaling group to create my instances. So I'll go here. I'll go to my auto scaling group. Okay, for once, okay. First, I'll go to my launch template, and you can see this is the launch template, and it has two versions of it. Okay, it has two versions. So I'm going to create one more version. To do that, go to your instance, which is part of your auto scaling group, and click on Actions, Image and Templates, and Create Image. It's going to create the image, and it's going to save all the configuration that I've done on this instance from here. Any doubts in this, guys? What I'm trying to do? All good or not good?
Yeah, it's good.
Okay. So all I'm trying to do here is I'm trying to create a custom AMI with all the steps that I followed. So let's use web app 2 as the name. Description is optional. I don't want to reboot the instance, so I'll just keep it. I don't want to reboot. Don't reboot. Okay. Then let's add a tag to this web app 2 and create the image. So it's going to create the image. Whatever steps I performed here, all will be captured in this AMI. We just have to wait for this AMI to become available. Okay. So you can check the status. It's pending. It should become available. Shouldn't take long because I haven't done much because already the steps were performed yesterday on this instance on this AMI because the instance was launched from the AMI that I created yesterday. So I had all the things already. Okay, so it saved some time. But for you, it's going to be the first time, so it might take a little longer. So we'll just wait for this to become available, and then we can update our launch template with this new AMI. We have half an hour, so we'll be able to finish this demo. Okay, till the time it is getting in ready status, I'll just show you how to update the launch template. So you can go to your launch template, and you can go to Actions and modify template, create new version, and here you can just specify anything. So for example, I can write web app 2, the name of this template version that I'm creating. Okay, source template is going to be your default version that you already have. It's going to come up automatically, and what you have to do is you have to update the image here. Okay, so you can go to browse more AMI. You've been signed out. Okay, strangely I've been signed out, so I need to re-log in. Password. That's it. Okay, I'm logged in, and okay, I'll do it again. So I'll name it as web app 2. Source template, it will come automatically. Whatever is the default version, it's going to come here automatically. So we don't have to change anything there. We just have to update the AMI. So browse more AMIs, go to my AMI and search for the AMI with the AMI ID or AMI name. This is the AMI ID that I just created. So it is web app 2. You can select it and just wait for a bit till it updates it. Updated web app 2. Okay, and let's check the status of the AMI also. Okay, I've been signed out, so I need to reopen that. No problem. You can click here and go to AMIs directly in a new tab. So web app 2 should have been become available by now. Yeah, it has become available now. As you can see, web app 2 has become available. Okay, so I can use it. So here I've updated the AMI. We don't need to do any other change. Everything is already there in our instance. You don't have to do anything. Just get the template version. It's going to create another template version. You can click here. You can go to actions and then go to set default version. Okay, so here I can choose the version that I want to use. I want to use web app 2 version, which is version 3 will be my default version, which means that when autoscaling group creates the instance, it's going to use this version because it is a default version in your launch template. So it's going to have all the things that I want in my updated AMI. Set as default version, it's done, and it's going to be automatically updated to your autoscaling group also. You don't have to change anything there. It's going to take everything as from the default version only. So this is done. This is done. Now we can perform ASG instance refresh, which I was talking about. So you can go to your autoscaling groups, click here. So we already have this one instance with the earlier AMI, but I want to update it with a new AMI. So you can go to instance refresh, start instance refresh, and we can use the default option, terminate and launch. Let's keep it everything as default. Don't need to change anything. And we can use replace here since it's a demo setup and it's going to take some time. So it's asking how do you want to do it. Okay, you want to launch your instance before terminating the other one. So you have all the options here, but I just want to make it slightly quicker. So I'm using terminate and launch. It's going to be faster and this is going to be slightly slower. And similarly, I'm choosing all the options as it. I just want to replace the instance straight away. Okay, I don't want to keep the instance. Start instance refresh. So it's going to terminate the instance and create another one. Okay, straight away, as you can see. So within 1 minute or two, we will see this instance will be removed and this instance will come in service. You can click on this instance and check the details, especially the AMI one I want to check. So AMI, you can see it's using web app 2. The earlier one was using the this web app. So here we have this web app 2 configured as we expected. So this is how you do rolling updates of the instances as part of your this. As you can see, it has come in service and the earlier one has been removed. Okay, this is done. Now let's go here. Then I'm going to create a target group and an application load balancer. Now I will show you a demo of application load balancer. So first I'll go to ALB. So ALB again it's part of EC2 service only. So you can click ALB in another tab, load balancers, and create load balancer. You will see three options only. As I mentioned, this classic one is the previous generation. So you don't get it on top of the page, only in the last at the last you will see this. We're going to get an application load balancer. So choose application load balancer, click create, give it a name, and use demo ALB. And here you get the option whether you want to make it as internet facing or internal. For our use case, since I'm using the default PPC, I'm keeping it as internet facing. But if you have a use case where you want to keep it internal, you can do so. We're going to use IPv4. We don't need a dual stack. We don't need IPv6 addresses. We just need IPv4. So keep it as default. Then here you can choose the VPC. I'm going to use the default VPC. Uh, this you can leave as it is. And here you get the option to choose which availability zone and subnets you want to use with ALB. So I'm going to use US East 1A and US East 1B availability zone. And in US East 1A in default VPC, I just have one subnet, which is going to be chosen automatically. If you click on the drop-down menu, you won't see another option because this subnet with this VPC has only one uh, subnet, which is public. Okay, similarly for US East 1B, it's going to be the same case. Then security groups. Here I already have one security group, which is allowing everything. Okay, so you can use that, or you can create a very restrictive security group. So what you have to ensure is when you're creating the security group, especially in real time, is whatever traffic you allow on the website should be allowed from the ALB also. For example, you have a website that is using port 80, the HTTP traffic. So you have to ensure that you allow port 80. Okay, but here I'm just using a default one, which is in allowing everything. So I can use this security group. It allows everything just to keep it simple. So it's okay. So, but if you want, you can keep it more restrictive. As I mentioned, you just need to enable port 80, okay, which is going to enable HTTP traffic on this ALB. Then this is the listener configuration that I was talking about. Here you choose the protocol and port. So by default, it's going to be HTTP. But if you have an SSL certificate, okay, which I'm going to show you in some other video. As of now, I don't want to cover this in this video. So if you have an SSL certificate, which you can use with port 443, so you can do so. You can choose HTTPS, and this entire configuration is going to change. Okay, I'll show you how it changes. So for now, let's keep it as HTTP port 80. I don't have any SSL certificate to attach right now. And here you have to create the target group. Okay, so you have to create a target group. I don't have any target group, a target group as of now. So click on this target group, and it's going to open in another window. So here you can configure what type of targets you have. Instances, IP addresses, you also have the option to attach Lambda functions, or you have another application load balancer, you can attach it with that. But for our use case, it's going to be instances, which means that EC2 instances. So we'll keep it as instances. And here you can write the name. Let's use demo target group. The protocol and port, I'm going to use HTTP 80 in my listener configuration of my load balancer. So it has to be same here also. So I'll keep it as default, and IP address type is IPv4. The VPC is going to be default VPC, and protocol version you don't have to change anything until you have some specific requirement to use another version of HTTP, or if you have some gRPC requirements. Okay, in some cases we use HTTP2 also, but in our use case we'll just keep it as HTTP version 1. Then here you can configure the health checks. Okay, you don't have to change anything until you have configured some specific health checks as part of your web server configuration. Okay, we haven't configured any custom health checks, so we'll keep everything as default. Only thing I'm going to change is the time period to save some time. For example, here I can change from 5 to 3 seconds, and interval I can just keep it as 5, and click on next. Okay, I don't have to register any target as of now. Okay, because it's going to be automatically added as soon as I add my ALB to the auto scaling group. Whatever instances are part of my auto scaling group will be included as my targets in the target group. Okay, so you don't have to do anything. Just click on create target group. The target group is created with a demo TG. Now go back to your create application load balancer UI and hit refresh. And now you will see that new target group popping up. Okay, don't have to do anything else. Just scroll to the very last and click on create load balancer with all the default options. The demo ALB is created. Okay, and it's going to take like 1 minute or two to become active. It's going to show a status as provisioning. And now go back to our document. So this is done. Now we can attach the ALB with auto scaling group. Okay, so how to do that? Go to your auto scaling group, go to integrations new, click on edit option, and here you get the option to attach your auto scaling group. I want to attach an application one, application load balancer. So choose this option, and here you get the option to choose the target group of your application load balancer, which is demo TG, and click on update. It's going to ensure that all the auto scaling group instances are part of my target group which is attached to my ALB, and it's going to start performing health checks also automatically. Okay, so we'll just wait for a bit. And here you can check all the information. Okay, if you have a requirement where you have to add an SSL certificate, you can create another listener. So this is HTTP 80, but we want port 443 with HTTPS. So you can go to add listener, choose HTTPS. It's going to change to 443 by default, but you have the option to customize this port also. And then you get the option what do you want to do. So I want to redirect all the HTTPS traffic to HTTP behind the scenes. So I can choose the target group, and after that you get the option to attach a security policy. So once again, the security policy, you don't have to change anything. In some cases you have to change. For example, I got a case wherein the ALB security policies were not covering some of the uh, algorithms, and I mean there was this security team which was using this tool called Tenable, and they run the entire what you call compliance and security scan on all of the AWS accounts, and they found that the ALB policy, the security policy that was attached, and whatever what do you call the different policy elements that were I mean part of the default ALB policy were not compliant to the security standards. So they send me an email that we have to change it. So in those cases, you have to read through all these different ELB policies on the AWS documentation and decide which one to use. But for our use case, we don't have to touch it. And I'm just giving you a very this random scenario in which cases you have to change it. Only you have to change it until I mean if you have received some notification from a security team which is running a compliance and security scan on the entire AWS account, and they found that there are some vulnerabilities that are part of the ALB this ALB configuration. In only in those cases you have to change it, the policy, else you will not have to do anything here. Then you have the option to use either certificates from a certificate manager service which is in AWS, or you can import your own certificate also. In my last organization, we used to import the certificates from another vendor called DigiCert. Okay, so we used to import the certificates to AWS Certificate Manager and then use it here. But in we can use the certificates from Certificate Manager service in AWS also. And here you can choose all the certificates. I do have two certificates, but these are not working at the moment, so I'm not going to use it. But you can attach the certificate in this way. Okay, just wanted to show you. Let's cancel out of it, leave, and let's check the status. It has become active now. So how to check if, okay, the first thing is you have to check the health of the targets, right? So for that, what you can do is you have to go to a target group. So health check will always be checked on the target group page and not on the ALB page. From here, you can click on this. It's going to open in another window, and you can go to health checks and check the status. It is coming as, sorry, you have to go to targets and check the health of the status. So you can see it's healthy, which means that the health check was performed successfully. Okay, and all the configuration is looking absolutely good till now. Now, if you want to check the status of your main website, if it's working or not, you can copy the DNS name of the load balancer. So this is the endpoint that I was talking about. Okay, this is the DNS endpoint that we can map to our this DNS configuration also. For example, I want to name this website to something like www.example.com. So I can map this domain name to that domain name of my choice, and I can just have a very, uh, I mean, real website name. Okay, so this is what we use to access the ALB endpoint. So if I just, I mean, copy it from here and go to another window and paste and go to this, it's going to give me this not secure one because I'm not using any SSL certificate, so I don't have any certificate. So it's going to be not secure. I'm using HTTP only. Okay, so this is how you can access a website. So this is our website that we just configured on this instance. Okay, so as I mentioned, it's I just wanted to ensure that we have a real world looking website. So this is how you can install and configure a website on an EC2 instance uh, that is running behind an application load balancer. Any doubts still here, guys? Whatever I'm doing?
Yeah, one doubt for
Yeah, yeah, yeah,
me,
yeah.
Bao. So after creating the load balancer here with the DNS endpoint name, we will map that same DNS endpoint with the in the DNS route 53, right? With the with whatever the website name we want, we map there with no specific records or whatever it is.
Yeah. So it can be Route 53 or it can be some other platform also, depending, I mean, where you have your DNS configured. It can be
So
anywhere.
let us say if it is a GoDaddy or GoDaddy, but I'm specific to AWS. If it is in AWS, then it should be in Route 53 where we map it. If it is GoDaddy also, we can map there, right?
Yes.
Depending
Yes.
upon yeah,
Yes, we can do that. We can do that. We can
yeah.
map. So in my last
Okay.
organization, how we used to have for our public domains, we used to have one hosted zone in Route 53, and for our private one, we were using another DNS tool which was called Infoblocks. Infoblocks. So there we had all the, I mean, private DNS configured.
Got it.
Infoblocks. This is what we were using in my last organization as the, I mean, private hosted zone to host all the private endpoints and Route 53 for the public ones. Okay, so this is how we have configured. Now let's go back. Now we are going to create a dynamic scaling policy with that CloudWatch alarm. So this is the step that I was talking about, that we had some issue yesterday, and I'm going to talk about the issue also and how I was able to resolve it. So now I'm going to create this scaling policy with my auto scaling group, and I'm going to create a CloudWatch alarm and SNS configuration as well, so that we can get an alarm, a notification as soon as a threshold is breached. I'm going to use every CPU utilization of the auto scaling group. So let's go to our auto scaling group, go to automatic scaling, create dynamic scaling policy. Okay, the scaling policy already there since I was using it yesterday. So let me just delete this and create another one. Delete, delete. Okay, so create dynamic scaling policy, and I'm going to use simple scaling policy for this. Let's use the name as SP. I also have one CloudWatch alarm, but I'm going to create another one. So let's click on create a CloudWatch alarm. Select the metric. The metric is going to be related to EC2 service. So choose EC2. And in EC2, I want to use auto scaling group metrics and not per instance metrics. And here you can search for the metric. I want to use CPU. So you can see the auto scaling group name is demo ASG, and I want to use CPU utilization as my metric. So you can choose it from here, select metric, and here's the issue. So what actually I did it again, and I had the same issue, and I raised the case with AWS to understand it. And I was on a call with them. So they told me that sometimes what happens when you choose this time period to be like 10 seconds or 20 seconds, the CloudWatch alarm doesn't have enough data points to decide whether to trigger the alarm or not. So it is always like the best practice to at least have it for 5 minutes. But I have seen this working with 10 20 seconds also in the past, but yesterday it wasn't working. So as a workaround, you can change the time period to 5 minutes so that it has enough data points to collect and decide whether to trigger the alarm or not. And this was the issue that happened yesterday. So I'll just keep it as default to 5 minutes, and let's keep the threshold value to 20. Okay, so that we can have the alarm triggered slightly quicker. Okay, so here what I'm trying to specify, I'm trying to specify the threshold value for my CPU utilization. It should be greater than 20 is when this alarm is going to get triggered. Okay, and I'm using the CPU utilization of my auto scaling group. One more thing he said that if you want to uh, do another change in your configuration is you can choose the treat missing data as bad Beijing threshold. So yesterday what was happening with our alarm, that it was not able to get all the data that it needs to decide whether to trigger the alarm or not. So in that case, you can use the last option, treat missing data as bad breaching threshold. In that case also, it's going to breach the threshold, so it's going to trigger the alarm. So this is one more option that you can use to trigger the alarm for you. Okay, but once again, as I mentioned, I have used this and previously also multiple times, and it has worked with the default options also. But in this case, since it wasn't working yesterday, so I'm going to choose this option so that it is triggered. Next,
Can you walk through
yeah,
that the four metrics, whatever is there as as part of the metrics, Babuk?
as part of the matrix where in
Yeah,
cloud
the
cloud,
down. Can you come down?
yeah,
Step like here.
this one,
In the
okay,
additional configuration,
yeah.
treat missing data as bad. What exactly are the other three? Not breaching threshold, maintain the alarm state, and all. Treat missing data as bad. Okay.
So
Uh,
this is the default one which is chosen. Okay, so if it
Okay.
is not able to pick up any data, it's going to treat it as missing data, and it's not going to trigger any alarm.
Okay.
Okay, if you want to treat this missing data as good, you can do so. So you can treat it as good, and it's not going to reach the threshold. Is one more thing,
Okay.
and then you have another option. If you want to maintain the alarm state whenever the data is missing, one more option. So it's going to be in alarm state at all times. But what I want,
Mm,
as soon as I have any missing data, I want to treat it as bad, and the alarm should be triggered.
Okay. Okay.
Got it?
Got it.
Just some random options.
Yeah.
So
Yeah. Yeah.
this was the default one which we were using, and it was getting some issues. So after I had a call with AWS, so they suggested you can use this one so that your alarm is triggered quicker. So if in case we are not able to get the data, it's still going to trigger the alarm and trigger the scaling event also for us.
Got it. Got it.
Okay, so next. So, one more thing, I created the a topic separately. So let's get another topic from this platform only. You can do so. So let's use CPU util, and just randomly I can add any numbers. CPU util U98 is going to be the name of the topic that I'm going to create right from this console. Okay, I'm not going to create the topic from SNS. We can do so from here, and here I can mention the endpoint where I want to receive the notifications. I have to create topic. It's going to create a topic for me with this name and add this as an endpoint. And we don't have to do anything. Just click on next. Name the alarm. Let's use the same name, CPU util 098. Next, review everything and click on create alarm. As soon as I did it, I will see one notification to confirm the subscription. Okay. So since I use this this particular email address, I'm getting an email from AWS to confirm the subscription. So just on a very high level with SNS, what you do, you create a topic, okay, and you can subscribe to that topic using one of the email endpoints, one of the email addresses, basically. So here it is just asking whether you want to confirm the subscription or not. So whatever events happen with that particular topic, all the notifications will be sent to my inbox after I confirm it from here. Done. I'll just delete this one just to keep simple. I'll go back and I'll just okay. So now next step is to so this is done. Now I have to run a CPU stress test on my auto scaling group and check if scaling event triggers. Now we have used this average CPU utilization as a metric, so we have to ensure that CPU utilization is going over 20% to have the alarm triggered, SNS configured, as less alarm this SNS alarm notification sent to my email ID, and my scaling event should trigger. Any doubts in this? How these things are linking together? Anyone? Let me know if you're not able to understand any part here. Okay, if not, I'll just move ahead. All right, so I'm going to run CPU stress test. I'm already logged into the machine here. Okay, actually I'm logged out, so I'll just go to the console and pick up the latest instance. So if you see, instance is okay now. Okay, so it has to be in alarm for it to trigger. So when the alarm gets triggered, it's the state is going to change from okay to in alarm, and whatever you have configured with your CloudWatch alarm is going to trigger as well. In our case, it's going to be the scaling event. So alarm has been created. Okay, I didn't get the configuration of scaling policy, so I'll do that. So I have to choose the alarm here. Alarm is this one. I just get it. And what I want to do, I want to add one instance to my auto scaling group as soon as this alarm is triggered. So I'll just get this. The scaling policy is created now. You can check. Uh, so it clearly says that it's going to execute when it breaches the alarm threshold, which is for 20 for one consecutive period of 300 seconds, which is equal to 5 minutes. Auto scaling group name is demo ASG, and it's going to add one capacity unit to my auto scaling group. Okay, this is done. Now I'm going to log into the instance itself. So auto scaling group, go to instance management, click on this, and log into this instance. Connect, copy, and sorry. Once again, if you're using custom AMI, the user name is going to be changed to root, but it has to be EC2-user. So for stress test, the commands are also given. First become root.
Hello.
Hello, can you hear me?
Sorry, Bhavuk.
All good now?
Yeah, we are able to hear you.
Okay, okay. So here, just become root and install this packages. Maybe we don't need it, but let's try to run this command and see. Okay, we don't need it actually, so we can install stress package directly. Stress package is installed. Okay, now I'm going to stress out the CPU. So I'm going to simulate that CPU utilization uh, so that it is over 20. Okay, so it's going to stress out my CPU, and we can check the status here also. In the monitoring section also, you can check the CPU utilization of your instance. Okay, if you keep hitting refresh, maybe we can change the period to 15 minutes. And if you hit refresh, you will see the CPU utilization is going to increase. Or you can check from the OS also using the top command and other commands, which shows the status. And also in alarm section, it will change to in alarm. Okay, so this is the alarm that we are talking about here. So we'll just wait for 5 minutes. I think it's going to trigger the alarm, and it's going to add one auto scaling, one instance to our configuration automatically after the scaling event triggers. So we'll have to wait for a few minutes. As I mentioned yesterday, we had an issue using the time period as 10 seconds, 20 seconds. It doesn't work. Sometimes it doesn't work. In the past, it has worked for me. So we'll have to wait for a few minutes. This I can delete actually. So actions, delete, delete. So this is a very good project, especially if you're appearing for a cloud role, okay? AWS cloud role, you can explain this step by step. And once you learn automation also, I mean Terraform automation, then it's going to be like uh, icing on the cake. So this is one of the projects that you can do. You can tell them that this was a scenario which I just spoke in this. This is the scenario that I was working on. You can use any example. This is one of the scenarios that you can use in your interview also. But you should be able to explain the entire architecture and how you configured each and everything step by step. If you're able to explain this, you'll be impressed for sure. Yeah, so this was the issue that I was not using 5 minutes because it's going to take slightly longer. So the CPU is increasing, you can see. So it has to reach this point. What we can also do, we can uh, run another test to increase it further, or we can check the status first. How much is the current CPU utilization on the instance? Using the incorrect IP address. Let's check the status here. Top command, Shift P. So it's using 99.2 already. So it's going to trigger pretty soon. Let's check here. But as I mentioned, it's going to take into account 5 minutes. So let's wait for 5 minutes. 2-3 minutes have already gone by. I hope that, there's no issue today, because yesterday I tested everything in the night and it was working. So let's just see. Looks like it's going to work, but CPU utilization is 99.7 of this test process. So it's consuming all the CPU now. Okay, I think there's some issue again. So what we can do is, another thing we can change here is, when you see anything like that, you can edit and you can, okay, no, I think it triggered. So let's just cancel out. Let's go to alarms. Okay, in alarm, yeah. One more thing I wanted to change, I'll show you. Uh, so now the alarm has triggered. You can see after 5 minutes, it just waited for 5 minutes, collected all the data points, okay, from my CloudWatch metric on the instance, and realized that the CPU utilization has breached over 20%. So it is an alarm. And if I go to my email ID, you can see a new email. As you can see, a new email has came from AWS, and it clearly says that threshold crossed 1 out of 1 data points, 99.7 was greater than the threshold at 20 minimum. Okay, so it triggered the alarm. Okay, this is fine. Alarm is triggered. We received SNS based notification as well, email notification as expected. Now I'll go back to my auto scaling group to check if the scaling event was triggered in response to this CloudWatch alarm. So automatic scaling, we can go to instance management directly and we can see one more instance was added to the instance to the auto scaling group. Earlier on there was only one instance. Okay, the instance capacity can go up to 2, so one more instance was created just now. Okay, and the earlier instance, if I go to instances here, this I can remove, this I don't need. Terminate, terminate. This is the older instance. So the two instances that are there is these two. So apart from the one that I was using to do all the configuration, to do all the stress test, I have another instance created. So you can see the status check is initializing. So it's still uh, not 100% ready, but this is how the scaling event got triggered. Okay, any doubts in this, guys? Any doubts how we are able to trigger the scaling event on behalf of the CloudWatch alarm trigger?
No, 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 all good.
All good, all good. So this is a very good project. I highly recommend that you do this on your own. Once again from memory. Okay, try to learn the architecture first, step by step. Okay, try to read out everything what I just said in this video. Okay, and just try to create everything from scratch from your memory, one after the other. Okay, start from very scratch. Start from IAM user and create the launch template with the custom AMI, and then create the auto scaling group, then ALB, then configure your ALB. Okay, and I mean, if you can do, I highly recommend that you create VPC also along with it, like the full end-to-end, where you are using custom VPC along with all the other things that I have done so far. So it's going to be like full project, full AWS project that you're doing right from scratch. Okay, so in this way, you're going to get a lot of hands-on practice. So this is how you develop your cloud skills. Okay, do as many hands-on projects as possible. So this is one of the hands-on project that I was talking about, and I'm going to come up with more in the future. All right. If no doubts, I'll close out the session and we'll talk again tomorrow.
Okay, Babu.